Imagine watching a massive live broadcast, like, say, the Super Bowl, and the sound of the referee's whistle hits your ears like half a second after you actually see him blow it.
Yeah, that totally ruins the illusion of live TV, right?
Right, exactly. It shatters it instantly. Well, today we are looking at the $1,000 metal box that basically prevents that exact disaster from happening. Welcome to today's deep dive.
Glad to be here. We are digging into a product catalog page from HDTV Supply today.
Yeah, specifically, we are looking at a piece of hardware called the AJA 3G-AMA 3G-SDI Analog Audio Embedder Disembedder. It is a bit of a mouthful.
It really is a mouthful.
Yeah.
But our mission today is to, decode all that heavy technical jargon on the spec sheet. We want to figure out how this hardware actually works.
And, understand why AV professionals willingly drop $1,035 on it.
Right, the price tag is definitely something we need to talk about.
So to quickly visualize what embedding and disembedding actually means in a professional video signal, I like to think of it like a sandwich.
Okay, a sandwich. I like where this is going.
Right, so the visual data, the actual video feed, is your bread, and the audio is the meat.
Makes sense.
So this AJA device lets a producer surgically remove that meat, maybe to run it through an external mixing board to adjust the levels or something. That is the disembedding part.
Exactly. Or, they can embed new meat, like inserting a translated commentary track right into the middle of it.
Yeah, and doing all that without touching or ruining the bread.
And doing that on the fly with a 3G-SDI stream running at 1080p and 60 frames per second requires, well, serious processing precision.
Because if you mess up the timing even a little bit, what happens?
You drop frames, or you get that awful digital artifacting on screen. That is where the specific routing capabilities of this device really shine.
Oh, right. Let's talk about those capabilities.
Yeah, so the disembedding function is actually always active.
Mm.
It is just constantly outputting 4 channels of balanced analog audio.
Wait, always active. So a producer just always has the option to grab that original audio feed if they suddenly need it during a live show.
Exactly. It is always there waiting for you. And while it is doing that, at the exact same time, the embedding side is user selectable per channel pair.
Meaning you have options on how to handle the input.
Right. You can either pass that original audio straight through, or you can inject completely fresh audio using the XLR breakout cable they give you.
And honestly, the fact that AJA includes that breakout cable right in the box is just a huge time saver.
Oh, for sure. It means a tech isn't frantically hunting for some proprietary adapter in the middle of a high-stress live production.
Yeah, nobody wants to deal with that. But I do have to push back a little here on the cost.
I figured you might.
I am looking at that $1,035 price tag. Couldn't a basic, cheap adapter you just grab online do the exact same thing for way less?
Well, a cheap adapter might work perfectly fine for a static home setup, but in live broadcasting, you are dealing with this thing called compounding lag.
Compounding lag. Okay, break that down for me.
So if you have a tiny bit of delay at the camera, right, and then a little more delay at the switcher, and then a bit more at your cheap audio adapter.
Oh, I see. It all adds up.
Exactly. Suddenly, those delays stack up,
Yeah.
and the lip sync is just noticeably off for the viewer at home. This AJA device completely prevents that compounding error.
Right, because it automatically detects video standards and even supports HDR pass-through.
Yeah, and it processes the signal with latency measured not in milliseconds, but microseconds.
That is crazy. Let's actually look at those numbers because the discrepancy in the specs here is super fascinating.
It really is. What did you find?
Well, depending on the input, the video latency ranges from just 3.2 to 17.2 microseconds, but the audio latency for both embedding and disembedding sits at roughly 1,100 to 1,200 microseconds.
Yeah, that is a pretty big difference.
Right. Why does the audio take nearly 100 times longer to process than the high-resolution video? It seems backwards.
It does seem backwards, but it actually comes down to the mechanics of digital to analog conversion.
Oh, okay. How so?
Well, the video is a digital signal just passing straight through the hardware. But the audio is being actively converted from a digital stream into an analog signal for those XLR cables.
Or vice versa if you are embedding.
Exactly. And that translation, that conversion, requires some pretty complex math and buffering inside the box.
That makes a lot of sense. But even so, 1,200 microseconds is still, what, only about 1,000th of a second?
Yeah, basically. So to human perception, it is perfectly instantaneous. You would never notice it.
And in a live broadcast truck, where literally every single second counts, you don't even need to boot up a software interface to configure this thing.
Nope, you really don't. You can just flick the physical dip switches right there on the side of the box.
Or just plug it in via USB if you do prefer the software control route.
Right. It basically functions as this microscopic, super high-speed switchboard.
Just ensuring that the visual data and the analog audio are perfectly merged before being beamed out to millions of viewers.
It really highlights the sheer amount of unseen infrastructure required to make live television look completely effortless.
It really does. So the next time you are watching a flawless, high-end broadcast, remember there are invisible workhorses like this sitting in a rack somewhere.
Just furiously doing the math to keep your audio and video perfectly glued together.
Absolutely. Well, before we wrap up, we want to leave you with a final thought to mull over.
Something to think about after the show.
Yeah. As the entire media production world races toward wireless IP-based digital networks up in the cloud, why do physical hardwired tools relying on old-school analog XLR cables remain the absolute trusted gold standard in live broadcasting?
It is a great question. It really makes you wonder what critical reliability we might actually be sacrificing in this huge race to go fully wireless.
Definitely something to explore on your own. Thanks for joining us on this deep dive, and we will catch you on the next one.